Welcome. In today's session, we will be looking at the reaction mechanism of pyruvate dehydrogenase complex, the PDHC. So this complex, it is composed of 3 enzymes, namely pyruvate decarboxylase or the pyruvate dehydrogenase, the dehydrolipol transacetylase or the dehydrolipol acetyltransferase. We also have the dehydrolipol dehydrogenase. Also, we will have 5 coenzymes which are in the complex, namely thiamine pyrophosphate, lipoate, flavin adenine dinucleotide, nicotinamide adenine dinucleotide, and coenzyme A, vitamin B5. So, how are these coenzymes linked to the enzymes? So, like this. This thiamine pyrophosphate is the prosthetic group of pyruvate decarboxylase. The other name of pyruvate decarboxylase is pyruvate dehydrogenase. We will see why both names can work. So, let me use another color. Lipoate is linked to dehydrolipol transacetylase. Flavin adenine dinucleotide is linked to dehydrolipol dehydrogenase. First, understand that. Okay, then let's go to the reaction mechanism. So we will have only five reactions. Only 5. They are named here 1, 2, 3 here, sorry, 4, 5. These first 2, reaction 1 and 2, they are catalyzed by the first enzyme of the complex, the pyruvate decarboxylase or the pyruvate dehydrogenase. Reaction number 3 here is catalyzed by the dehydrolipol transacetylase, which is also known as the dehydrolipol acetyltransferase. Reaction 4 and 5 is catalyzed by the dehydrolipol dehydrogenase. Just understand that. Okay. Then let's go to now the actual reaction mechanism. We said pyruvate decarboxylase is linked to thiamine pyrophosphate. Then thiamine pyrophosphate, it comes in with water. So I will write here water, but I will not write water. I will write HOH. You know that is water, H2O. Yes. So this is what happens. You see this. This, the one I'm pointing here, COO, is removed as is lost as CO2. That is why if we are removing a carbon, that is why we are calling the enzyme a decarboxylase. You have seen the sense? Then we remain with a 2-carbon compound where we add a hydrogen. I said TPP comes in with water. So we will add a hydrogen here and this, and so after adding a hydrogen there, we will also add another one here. Okay. I hope you have seen that. So we will form this, I can call it a hydroethyl derivative. A hydroethyl derivative which is linked to thiamine pyrophosphate. Okay. So maybe you can read here. Pyruvate is decarboxylated to form hydroether derivative bound to the reactive carbon of thiamine pyrophosphate. Thiamine pyrophosphate, as I had said, is the coenzyme of the pyruvate decarboxylase or the pyruvate dehydrogenase. So in the second reaction, which is also catalyzed by the same pyruvate decarboxylase, we will take the dehydrolipol transacetylase, which is linked to lipoate. Then in lipoate, we have a lysine group here. So like the lipoate usually exists in 3 states. This is the first state. Let me do that. This is the first state. This state is oxidized state, that one. This, then this is the second state here, acetylated state. Then the third state is this one here, the reduced state. So lipoate usually exists in those states. So in this second reaction, also catalyzed by the pyruvate decarboxylase, we will take this, the hydroether derivative, we add it with the lipoate here. Then we will generate, the reaction is proceeding upwards like this to generate our TPP here. We will generate our enzyme, which is linked to thiamine pyrophosphate. Then this hydroxyether derivative is the one transferred to lipoate. Okay, so now once it is transferred, can I call it that? And that is an acetyl group. Now this is the acetyl group which is transferred to the lipoate. Once transferred, the dehydrolipol transacetylase will, as the name says, will transfer it. And in the third reaction now, we will add a CoA. Okay, a CoA is added. This reaction is the one which is catalyzed now by the dehydrolipol transacetylase. Once we add a CoA, we will form an acetyl CoA here. As you can see, this was the acetyl group. Then we add the CoA there. This is the CoA, the one I'm trying to underline. That is the CoA we add. Then this, we cleaved this bond here. We cleaved here up to there. Then let me, maybe I use another color. Maybe these colors will now start confusing some of you. Yes, here we cleave this bond here. After cleaving that bond, this is where we add the CoA. But remember, in CoA usually comes with an SH group. So we remove that hydrogen and we will add the CoA plus the sulfur, the CoAs. So is the one added as shown here, as you can see there. Then that hydrogen is added to this sulfur here. Okay, the hydrogen which was removed from the CoAsh. So it is added as shown here. So now this form of lipoate becomes the reduced form. If you can remember, what is reduction? Gain of hydrogen. So it is reduced, as you can see here. But we don't want it in reduced, we want it in oxidized form. So in the other reaction, this is now the reduced form. Now in the fourth reaction here, this reaction is catalyzed by this, the dehydrolipol. Maybe I should underline it. It's the one which is catalyzed by the dehydrolipol, dehydrogenase. Now, this dehydrolipol dehydrogenase will catalyze this reaction. Sorry for that. Will catalyze that. This will catalyze this reaction where it is FAD linked, where this hydrogen now, this one and this one will be attached to FAD to be released as FADH2. Okay, so with that it has now, this is the reoxidation step. Now lipoid has ceased to be reduced, now it is oxidized. So this is reduced to oxidized. So FAD, we also need to remove these hydrogens from FAD. That is where now this, we bring in the NAD. The NAD will reduce FADH2 to FAD. This is removal of oxygen. Removal of hydrogen is oxidation. We reoxidize. It will reoxidize FADH2 to FAD. This reaction is also catalyzed by the same dehydrolipol dehydrogenase to give us our NAD and our hydrogen, which will now go to the electron transport chain. Maybe you should read these notes. So we had done for one. So in the second one, where we said it's also catalyzed by the pyruvate decarboxylase, the either intermediate is oxidized by the transfer to the disulfide form of lipoic acid covalently bound to the dehydrolipol transacetylase. Remember I said lipoate or lipoic acid is the coenzyme of dehydrolipol transacetylase. The other name of dehydrolipol transacetylase is dehydrolipol acetyl transferase. Then in the third one, this reaction is the only one which is being catalyzed by the dehydrolipol transacetylase. The acetyl group bound to the thioester of the side chain of lipoic acid is transferred to a CoA. Now it becomes a thioester of CoA, the acetyl CoA. Then in the fourth reaction, the sulfhydride form, or this is the sulfhydride form of lipoic acid is also the reduced form of lipoic acid is oxidized by the FAD dependent dehydrolipol dehydrogenase, regenerating the disulfide or the oxidized. This was the oxidized here, the oxidized form of lipoic acid. Then FAD on the E3 here means E3 is that enzyme, the dehydrolipol dehydrogenase is reoxidized to FAD as NAD is reduced to NADH and hydrogen. Remember, NADH and hydrogen will now go to the electron transport chain where they will it will donate its hydrogen to the nicotinamide adenine dinucleotide dehydrogenase, which is linked to flavin mononucleotide, maybe the complex one of the electron transport chain. In short, it will go to the electron transport chain. Okay, so that is what happens in those 5 reactions. So after that, we have already formed our acetyl CoA, which now will enter the Krebs cycle. Okay, Krebs cycle, I think I have a video, you should look at it. And yes, thank you for your attention. If you want the slides, you can email me. I will attach the email to the description. Thank you.